on this computer. All righty, it looks like it's recording. Hopefully people heard that. I'm just going to change the presentation view so that we can all see Oz.
I'll make a change.
The change now?
Yes.
Okay. So just a brief introduction, everybody. Welcome to the second meeting of the Quantum Ethics Reading Group. I'm really excited to have you all here and to introduce Oz. Oz has put together a presentation summarizing two of the readings for this week, which are Weapons of Math Destruction by Cathy O'Neill and Towards a Different Spin. These two readings combine ideas of artificial intelligence in society and what that might mean for quantum. And I'm very excited to hear what Oz has to say. As always, feel free to chime in with questions or comments throughout. We are going to record the initial presentation, but we will turn recording off when Oz finishes so that the majority of our session can be open discussion. And with that, I'll turn it over to Oz.
Yeah. Thank you for coming. So our first reading was Weapons of Math Destruction by Cathy O'Neill. So a little bit about the author. So she did her undergrad and PhD in mathematics. So she did it in, I think, algebraic number theory or something like that. And then after that, she left academia for a finance job, which is a very common path. And after working for about a year, the 2008 financial crisis happened. And that's when she realized that these algorithms and these models that these finance companies were using was actually kind of harmful, right? She realized just how much these are like recklessly being used and how much of like the effect on the society is just being held by a handful of people, the data scientists, right? Yes. And then she went on to write this book. Actually, she wrote 3 books. Her first book was just a textbook on how to do data science. And their way.
Yeah, I'm just kidding.
Sorry.
So we can see the quote. There.
Yes, and this was her second book. And she named, I really love the title, but this is a quote from the introduction. And I really love this quote. It says, like gods, these mathematical models were opaque. Their workings invisible to all but the highest priests in their domain, mathematicians and computer scientists. Their verdicts, even when harmful or wrong or harmful, were beyond dispute or appeal, right? Because you can't really argue with the data. That's objective and it's just very hard, the truth. That's what they say. And they tended to punish the poor and the oppressed in our society while making the rich richer. So she came up with a name for these harmful kinds of models, Weapons of Math Destruction. And in the introduction, she has one of the examples. So there are many examples. I bet many of us can even think it has been with the rise of AI and stuff. But this is the example that she was giving. So the District of Columbia Public Schools had a goal that they were going to improve public education, which is a very noble goal. And they said, let's not have any bias. So how can we have how can we rank the teachers in an unbiased way? And so they went to Mathematica Policy Research, and they said, okay, guys, can you guys give us an evaluation tool that would rank these teachers and would make them so that we can weed out the bad teachers in an unbiased way? Because like, oh, what if the principal really likes that teacher? You know, there's some sort of like bias in that. So with the help of an algorithm, we can not have that. And so this looks good on paper, right? But obviously it was not. So here's one of the teachers that was affected. So this is Sarah Wysocki, sorry. And so she was a very beloved teacher, actually. She was a 5th grade teacher, and the students' parents were really, like, they really loved her, and even the principal and like the community just really liked her. But once these, the tool is called Impact, by the way, once this was being rolled, she got a miserable score. She did not pass. the algorithm said, this is a bad teacher. And she was fired. So, you know, I can understand the algorithms being used to rank, but to going as far as firing, just based on this one Mathematica, like just on this algorithm, like that's insane. But yeah, so obviously she was like, wait, how can I be fired? Like, you know, I was getting good reviews from like everyone. So she went out to look for like how they evaluated her, you know, what was their, like, on what basis are they firing her? And what she, so along with other teachers, of course, like around 205 teachers were fired, but for years this went on. But then the teachers were like, of course, like, what are you using? And what they got as answer was that this is an algorithm. This is a complex algorithm, and we churn the data, and you would just not understand. This is the algorithm that we use, and you're a bad teacher. So of course they couldn't really say anything because they weren't data scientists. So what can they do? Like, you know, you go and you try to appeal, and they're like, well, we did our job. And this is not the only example of using the weapons of math destruction. There are many others, of course, that we've been hearing. For example, racial bias found in a major healthcare risk algorithm, again, using a singular algorithm to use and like to be used by the like either healthcare or the public schools. It's just insane. But or, you know, to optimize, again, all of these are on the basis of optimizing some sort of job, right? They use AI, and AI, of course, was biased, and it was found that it favored men for technical jobs. So this was, yes.
This is an important point that Cathy O'Neill makes throughout her book. In the case of the teaching algorithm, in the case of the health algorithm, in the case of the recruiting algorithm, where not only is the model inaccessible, it's a black box, and often is protected by intellectual property. So you physically can't access how it works. But the verdicts of these algorithms, the scores that they provide, are treated as objective, perfect truth. And because of the fact that math is complex for most of the population, people tend to shy away from it. When you find an algorithm that is being sexist or racist or firing good teachers, it becomes very difficult for anybody who is negatively impacted to change it.
Yeah.
So again, the inaccessibility of the inner workings of the algorithm is one feature of a WMD. And then another is that the WMD's performance isn't being reviewed. Like in a machine learning context, you produce some outputs and you evaluate how good they are, and then you train again. But these, you train the model once, and then everything it says from then on is treated as perfect. That's a big source of harm in a lot of these algorithms, and they're everywhere in the economy. So these three core examples that Oz is showing are really crucial because they illustrate job and sexism in work, they illustrate racism in health, and they illustrate good teachers being fired. But think, there's thousands more of these examples of these sort of big data and AI systems being used to generate harm that nobody can really challenge because it's an algorithm. It's true. So keep going. It's a perfect point.
Yes. So, I feel like if you went up to the people who worked on these, like if you went up to the data scientists and you would say, like, this is terrible, what are you doing? I imagine that like they will say, well, it's kind of inevitable. Like we didn't know that was gonna happen. It just happened so fast. We just blew up. And how would we even imagine the consequences? Like we wouldn't know. So yes, I would like for you guys to think about that a bit. Like what would you say back to them? Because like, I feel like they would say, oh, it happened so fast. And oh yeah, go ahead.
No, that's something I thought was interesting too.
Make sure you speak up just so people
Oh, yeah.
No, that's something I thought was interesting too, because like it sounded like also in that introduction, like it was like they can just kind of say, oh, like, well, that was just like one mistake, but like it's helping way more people. So like these small mistakes, it actually isn't a big deal, and it kind of minimizes the issue. And I thought that was like interesting too. It's like saying like, oh yeah, because this was bad to you, it's still better. It's just it was bad to you this one time, which I thought was interesting.
And I think the term they use, which is terrible, this is just collateral damage. The good teachers who have been fired, it happens. None of the algorithms are perfect. Like this is people's lives. But yeah, go ahead.
Like what you were saying, just because something's never going to be perfect doesn't mean we can't improve it. This is like saying to construction workers, oh well, you don't need to wear a hard hat because accidents are going to happen no matter what. And it's like, no, things to minimize these damages. Also, I find it so crazy, like this point you're making, where people take this algorithm as gospel, because like I've taken stats courses where the entire thing is you make a model to model some data, and then if someone comes up to you and says your model sucks, look, it's completely wrong, I have some data to prove it. If you say cry about it, that's in my mind, you would get like fired, and rightfully so. So why is it different here?
If the collateral damage, okay, if it damage equally on the population, maybe it's okay. But statistics shows that if you're more rich and you're more privileged, you don't get any of that.
Actually, that's a really good point, because I think that like the simplest thing would be like if the algorithm identifies these teachers as bad teachers, whatever that algorithm says, there should be an extra step of then like a human component of evaluating whether they're actually bad or not just like taking it. But I think that's also a privilege afforded to people. Like, because like even Wysocki said, like it says that Wysocki got a job at a richer school, like like people know that he's a good teacher. So it doesn't matter. It's just poor people who suffer the consequences.
Too. Like there was that quote that stuck with me in the introduction that was like, the rich get managed by people and the masses by machines.
Yeah.
That was I was like, right.
And this theme of inequity. We've
Go
got
ahead.
someone online.
Oh yes, I was just thinking like, even if we do add an oversight step where like you flag people and then you kind of evaluate them, that still doesn't eliminate the bias that this thing is going to keep flagging certain people, and those certain people will be scrutinized harder. So like even if you do say have a really bad teacher, but the teacher scores well, that bad teacher is not going to be flagged and marked and like evaluated to the same extent as a good teacher that scores poorly.
Oh yeah, this is great. So two kind of points. The point about inequity, social inequity, is a theme that was really prevalent in Cathy O'Neill's book. And the bottom line is that these systems are going to enrich a small number of people, usually white male privileged CEOs in tech companies, if a tech company can be white male. And the harms are going to be inequitably focused and concentrated in communities that are racialized, communities who are poor, women and gender diverse people. And this is kind of where like the key part of analysis is coming from, because as it was mentioned about collateral damage, if it affected the whole population uniformly, fine. You can't make an algorithm that's perfect, but we're making an algorithm that harms only certain types of people who are uniquely unable to fight back. And that's kind of where the unfairness comes from. And then the second point, and this is feeding into like what Oz was just saying, and the point that Oz is going to make coming up here, is that, she asked you to imagine someone coming to you about your model, because there are a lot of people in this room and online that are doing quantum machine learning projects right now. And so let's say you just made a model that harmed people. Would you be okay with that? I think I've never met a single person in my program who didn't agree with the fundamental premise that we don't want our work to hurt people. And from that premise, as developers of these godlike tools, the corollary is we have a responsibility to ensure they do minimal harm, and that those harms are not focused on these vulnerable communities. But the Oz is going to make similar points about what we can do about this and changing the culture, and this will be a big focus of the discussion. So keep going, Oz.
Yes. So so obviously we have this problem, And as we move on to having quantum technologies in our lives in the future, well, this is why we have this reading group, basically. But what should we strive for? And this is a manifesto, they use that word, on quantum technologies as a society. And just like Weapons of Mass Destruction, I love the title, Towards a Different Spin. So the first thing they say is basically, okay, the second quantum revolution is coming. We're gonna have like quantum cryptography. We're gonna be able to do things exponentially we're gonna speed it up. And like, they're gonna say, oh, this is it's gonna be so great. Everything's gonna be fixed in our lives. We're gonna fix climate change, right? So this is all the hype about it. And then there is also the other group, which is like, oh, quantum's gonna be used bad. We're gonna have warfare. And then, it can be used for bad things. We're gonna have a dystopic world. So what they say here is that every single time a new technology is emerging, these type of discussions happen. Like even when computers were becoming a thing, they had the same discussion. Like nothing is new actually. They were like, oh, it was a military, or like, it's gonna be like so dystopic and stuff. Oh, I'm just getting rid of that. So what they're saying is, okay, let's just not fall into the cliches of like the trajectory of new emerging technologies for quantum technologies. Let's strive for a different spin. Okay. So the first thing that they say that would not follow this is we need to dispel the myth that quantum is really hard to understand. So we have 3 Richard Feynman quotes. Anyone who claims to understand quantum theory is either lying or crazy. If you think you understand quantum mechanics, you don't understand quantum mechanics. I think I can safely say that nobody understands quantum mechanics. A bit projecting, but I'm just kidding. But okay, quotes like this, or those like really flashy titles and the pop science is actually harmful to the general public's perception of quantum. Because if Richard Feynman is saying these things, they say, oh, even physicists don't understand quantum mechanics. How am I supposed to understand quantum mechanics with like no math or physics background? Then we just completely shut them out of when the quantum technologies become part of our lives. Just like how it happened with big data, no? Now, it was a handful of people at like the Silicon Valley that grew all of these things. And because nobody else, because it was just a handful of people, by the time it got so big and just a regular part of our lives, like people just couldn't oppose to it. Like, yeah, basically that's. So what they're saying is, instead of having this, instead of perpetuating this idea that quantum mechanics or technology is hard, we should actually educate people. And yes.
Yeah, so this just tying in with these themes that Oz is connecting, where we have this similar problem where AI and big data models are treated as, oh, you'll never understand this, don't bother trying to challenge us. Quantum is going to be worse when it finally arrives, because quantum has this reputation coming from the creators of, like Feynman and others. And when we talk about what does this have to do with quantum machine learning, a lot of the projects that people in the room and online are working on are related to variational quantum algorithms. And I made this pie chart based on all of the papers that we were kind of sampling for this project. And there's over 20% of the applications of these quantum machine learning algorithms is enhancing machine learning, enhancing AI type of stuff, enhancing data science. And so here's a direct connection. When we talk about an unassailable technology doing harm through big data, quantum may well, the quantum advantage in that regime is a bad thing, because it means you're going to be harming those vulnerable populations we talked about before faster, exponentially, or more efficiently. So this is kind of how it all connects together, and connects specifically to the projects that are going on in this room. That If even 5% of those machine learning algorithms make it through and deliver advantage, we are in trouble. Or more specifically, the vulnerable populations that have no say or control over this are in trouble. And we, as the creators of this, have a responsibility to try and foresee these issues to protect those communities before they are harmed.
Okay. So what should we do? Again, we said educate, right? So, but they make a certain point to not say, and in the one of the quotes is saying, we are not simply advocating for improved modes of science communication and pedagogy. So they're saying, okay, not even science outreach is what we're trying to say. They're saying that quantum technologies must be familiar elements of the citizens' technological palette. I love that line, because they're saying that quantum should be a normal thing. Like, just like how we use fridges or our phones and like any of the other technologies that has like some like, you know, hard physics theory behind it. Once quantum technologies become like more like out of the labs and into the world, it should not be something that they still think, oh, quantum is like so weird, it's spooky, it's a woo and stuff like that. So that's why they really want, like they're saying, okay, it should be like a normal science. So that's a very important thing. And the second thing they say is how, okay, we say, if the quantum technologies are going to be a big part of our lives, the way we make and develop these, the culture of that should also change. So, for example, there has been a lot of discussions on the term quantum supremacy because it's reminiscent of white supremacy. So what they're, and a lot of opinion pieces say, okay, we need to change this world. We need to change it to like quantum advantage or quantum primacy and stuff like that. But what they're saying is even deeper, I think, and which is like, I really like it. They say, I would like to read the exact quote. The change in vocabulary terms would do little to address the underlying ideological values that make quantum supremacy such an appealing benchmark in the first place. It's the passage 6, if people are following through. They say not only between quantum computing and classical computing, but more insidiously between institutions, corporations, governments, and worldviews. So it's not that once we change the language or like, this is like putting a Band-Aid to all the issues that pop up as we keep going. Like this is, for example, one of the things. And as it develops more, it's gonna have another thing. And we're gonna say, okay, well, we shouldn't do that, but we should change it like this. I mean, like that's good, of course. But the way we should change the culture itself that makes these types of mistakes. Like if we change the culture, we would make less mistakes.
So the language is symptomatic
yes,
of the cultural
exactly.
issues that are underlying.
Yes.
Quantum is very non-diverse. It's very white. It's very male. It's very privileged.
Yes. So yeah. So that's what they advise us to do, to change the culture itself. So altogether, when they say what should we do, we should reject the idea that quantum mechanics is incompatible, so that more of the public could be active stakeholders. And we should educate the public in order for them to be actively involved. And we should change the toxic culture of physics so that we don't fall into the same problems as big data have. That's all my discussion.
All right, let's give Oz a pen. So this is kind of the jumping off point for the discussion. These are just kind of broad sketches, but we really want to hear what folks in the room and online have in mind. I'm going to stop recording now.